All right. Hello, everyone. My name is Brian Olsen. I'm a developer advocate at Starburst, and I work primarily in the Trino community. Today, I'm going to be talking to you, of course, for all of you here at Move Data. You're wanting to dive into all these Airbyte topics. So I'm going to actually talk about bringing Airbyte data in, using Airbyte to bring external data into a data lakehouse. And this is using Trino. So if you want to follow up with me afterwards, I'm at Bits on Data Dev, and you can also find me on the Trino Slack channel if you want to join there. So a little quick overview. A big thing I want to talk about is what is Trino, because you all know what Airbyte is. And so I want to give you a little background on why you'd want to use a query engine on top of a data lakehouse like this, like Trino. Then we're going to talk about, Trino, just like Airbyte, has these connectors that connects to multiple data sources. And so what Trino does is primarily focus on databases. And so we want to talk a little bit about how these two different storage connectors we'll have object storage connectors, and we'll have where Trino acts kind of like the client. So I want to make that differentiation there because there's a lot of connectors that we do and they're a little bit different, and we'll be using primarily the object storage when we're talking about data lakehouse. Then we're going to jump into the use case. That's going to be the primary meat of this talk. And then demo, I actually signed up for this not knowing this was going to be 10 minutes. So I'm actually going to leave the demo to you, and I'm going to have a video that walks you through this afterwards that you can come find and try to run through the demo yourself. So to start off with, let's get with the definition. So this is a mouthful, get ready. Trino is an open source, distributed, massively parallel processing SQL query engine designed to query large data sets from one or more heterogeneous data sources. So I've highlighted a lot of the key terms in this. It's very accurate, type of definition, but it needs a little more explanation to kind of understand all of these little pieces here. So let's start out with open source. So this is one that everybody here from the Airbyte community can kind of understand is Trino's open source. It's licensed under the Apache v2. And our big thing is we're a community-driven project. We believe that people primarily make up the open source communities and not particularly companies. So if you're a contributor and you're working at, let's say, LinkedIn or Netflix, if you move on to a different company, that doesn't revoke any of the work you've done before, or mean that anything that you are currently at, your current position, is going to get moved away. You're not, off the project or anything like that. This is opposed to kind of Linux Foundation and maybe other more company culture driven projects. Then so that's that one out of the way. The rest are more technical focused. So structured query language, SQL, is the language of choice and primarily the current primary way to interact with Trino. And it's a declarative language. So the reason why we've chosen this is it is much better to not to kind of take away some of the finer grained details from users that are just trying to basically get access to data, and let the query engine do a lot more of the work, the kind of cognitive load, so that you can focus on kind of the upper task of what you do with that data once it gets out of the data lakehouse. So SQL is a de facto standard way to do this around databases. And so it's become a much more common standard now with big data as well. So Trino follows the ANSI SQL standard, and primarily we've implemented a lot of OLAP features, which is the kind of analytics reading features, but we're now getting more into kind of DDL, DML, kind of insertion and writes for data in SQL, and we're supporting that more and more across the board, especially in connectors like Iceberg. So, so what's a large data set? So, this is always a relative term and people get confused by this. So large meaning, relative to the kind of initial boom of big data. This came out around 2010 area when Hadoop started hearing all those types of Hadoop related technologies, Hive and whatnot. And so, so this is what we're talking about. At one point we were saying gigabytes was big data at one point. After Web 2.0 and social media and a lot of these other big platform changes, we moved into petabytes being the kind of data, big data size that we were, kind of defining at that point. Variety of data formats. So you have anything from CSV, photos, all sorts of kind of unstructured data that you and your company stores as proprietary or something like that. And then, a lot more big data file formats like Parquet started to arrive on the scene. We need to also be able to process this large amount of data super, super fast to keep up with all the requirements that people in the real world actually wanted to keep up with. So Trino does all this, kind of doing this with interactive speeds, not quite real time. It says they're on the data velocity, but we are pretty much periodic to batch in that kind of spectrum. So distributed systems, that's how Trino does and achieves a lot of this interactive speeds. So we scale out, multiple workers. This is very common in a big data type of architecture. You'll have a coordinator that takes in a lot of the queries and then distributes the query plan and the schedule, across the workers. And then the workers are kind of the brute force that kind of executes a lot of these operations. And if we zoom in on that a little bit, I'm not going to go into deep stuff because we don't have time here today, but a lot of these operations can then be parallelized over threads and these various things we call pipelines, so that you can ultimately just get super fast turnaround. All this is running kind of streamlined in memory and trying to avoid blocking as much as possible or writes to disk or anything like that. Trino is incredibly fast because it avoids a lot of these kind of slow processes along the way, and just basically tries to be intelligent in terms of how it divides up the task and data based on how the data is. So the query engine part of it, a lot of people get tripped up on this as well. It's like, okay, well, it's a query engine, but does that basically make it a database? Well, no, it has the query engine parts, which are the parser, analyzer, planner, optimizer, scheduler, and executor. So it executes the queries, but it doesn't do data storage, locks, transitional processing, and a lot of these other kind of features that you kind of come to expect with, say, like Postgres or something like, Teradata or any of those kind of like big data warehousing systems. So what's the point of just a query engine is kind of the question you might ask if we've taken away all the storage. Well, what does it connect to then? Well, it connects to other databases to start. This one here on the right, it's, a Trino query engine connecting to one Postgres database. And you say, well, that's silly. Why do we have a query engine on top of Postgres? Well, it's because we can do it with a lot of databases. And so Trino handles heterogeneous data sources, meaning it can pull from, Elasticsearch, which are NoSQL databases, Snowflake, which is a big data warehouse in the cloud, Iceberg, which is what we're going to be talking about, which is the object storage connector, and so many more. And you can join data across all of those. So now that we have all of these that we're talking about here, we have object store connectors, and we have these things I like to call Trino client connectors, where Trino acts more as the, interacting with Elasticsearch via Java client, or interacts with BigQuery and Postgres via JDBC. It acts as a client in this transaction. And there's a whole separate instance of database that you're executing queries against through Trino. Then there's this other class that I like to call object storage, where Trino is the query engine, and it just directly connects to object storage through some format, which is, Hive, Iceberg, Delta Lake, or Hootie. And so, so that is the primary differentiation. And all of our data lakehouse stuff that we're talking about today sits in the Hive, Iceberg, Delta Lake side of things. So let's jump into the actual use case here. So we want to have some way to basically, query this data that, let's say we're pulling in from Airbyte, and we put into a very cheap storage. So we talked about data lakehouses. Why do you want to do that? Well, you want to do that because, for one, it's open. It's very open stack. So you're able to actually query open formats like Parquet that multiple query engines, not just Trino, can all act on and do different processing on. So you have your choice of, well, I want to use a query engine today, or I want to use Spark another day. And it's very interoperable versus just having everything's in, Postgres, and that's my only option now. So this is why data lakehouses are very, very strong, and using Airbyte to actually pull data in, let's say from GitHub, and then processing it into Parquet will make it super fast, and you're executing SQL on top of that. So why did we want to use Airbyte? I actually used this particular case of pulling GitHub data, and it's because Airbyte really removes the need to constantly maintain these shifting APIs like GitHub, and you're able to just write the data into object storage, and then I can use Trino or any other query engine to just query that data. It was really simple to set up. It's basically, you just pull up a Docker Compose instance. It's also very easy to just hop on over to Airbyte's kind of cloud service and just do it that way as well. So there's all sorts of options in terms of doing this. The documentation is incredible. I didn't even put that one, and the support's incredibly responsive. So the demo, here, I want to show you Airbyte plus Trino. It's really just better when you try it yourself. So head over to github.com/bitsondatadev/Trino-getting-started. That's the repository, and there's an Airbyte folder in there, and you just go in there and follow the instructions. You can play around with this yourself. If you need any help, I'm on Trino Slack, trino.io/Slack, and I'm Brian Olsen there. And thank you for hearing my talk. It was a really quick kind of intro to Trino and how you use Airbyte and Trino together. Thank you.